Welcome back to HANA Basics for Developers. So we've seen a couple examples of XSOData so far, but in all these examples, we've only done read operations. We've only requested to view data. But XSOData and OData in general also supports create, update, and delete operations as well. And out of the box, if your target is a database table, even the generic XSOData framework will work for those operations. But as you can imagine, once we start doing operations where we're altering or creating data, we might want a little bit more custom logic. Maybe we want to validate the data before it goes into the database. Or maybe we want to do the insert or create operation ourselves. And with that, what we have with XSOData is we have an exit mechanism. So that during certain operations like create, update, and delete, it basically drop into a coding exit where we can write our own custom SQLScript or JavaScript code in the form of XSJS that will be executed inside the generic OData service framework. So we don't have to create our own OData service framework from scratch. We don't have to deal with transforming the data to JSON or creating the metadata document. We can focus on just the parts where we want to code custom logic. And basically, this is very similar to like the ABAP enhancement framework in that we can have before exits, after exits, or override exits. So maybe we just want to validate some logic before the create or update operation takes place. We can use the before exit, do our validations, and as long as it passes, we still let the generic framework perform the actual create, update, or delete. We can have an after. Maybe that's just where some new data comes in. There's a create operation. We also want to write into a logging table or update a secondary table or something like that. Just an after the operation is already done. We want to do some additional processing. Or very common, we don't want the generic framework to do it at all. We want to completely take over the process. And this is very powerful because now we can use views as the source of our entity. And we can then decide, when the data comes in for a create or an update, we might redistribute the data to multiple inner database tables that are part of that view and still get the power of a single entity to the outside, but maybe it's multiple tables that we're actually performing operations on the server side. So let's go ahead and look at this scenario. So let's go back to the Web IDE and let us create a, we want to use the user entity for this scenario. And if you remember back, way back, we have our database module. That's what we're primarily connected to, but we've got this user DB, and inside user DB, we created a user data table. Pretty straightforward. We got a user ID, a first name, a last name, and an email. So something pretty simple that we can insert some new records into. And if you remember right, what we did is in our database module, we have some synonyms that also point to user DB. So we can access that user table from within our main database module. And what we want to do here is we want to use a view as the source of our OData service, because I want to demonstrate to you how you can have a view, but we can still have a create operation even on a view if we utilize exits. So we'll come here to DB source data, and we'll just go ahead in here and we'll create a new database artifact, and we'll call this user view. HDB view, and prepared a little snippet here for our view. And we'll put that in. And the other reason that I'm creating a view on top of, I'm creating view, user view as select from user data user. This user data user inside my container is a synonym. And one of the limitations of XSOData is I can't use a synonym as the entity source. So I could not directly use userdata.user in my XSOData, but instead I create a local view on top of that synonym, which works perfectly fine, and then I'll be able to use the view as my source entity in my XSOData service. So to get this new view in the database, let's just go ahead and rebuild the database module. And we've got our new view created. And now let's switch back to our XSOData and let's create a new service here called user.xsodata. And I've prepared a little snippet for it. Here we are. Once again, creating a service. Here's our entity, user view. That is our view on top of the synonym, which in turn points to a table in the other container. We will give it an alias, and we have to specify the key. And we didn't have to do that in our earlier services. If your source is a database table, then it will automatically know what the keys are to look at just the catalog data, and it knows the keys. But of course, if your source is a view, we don't have keys on views, so we have to specify a key within the OData service definition, and it is a requirement that all OData service entities have a key. So even if you have data, maybe aggregated data, where you don't really have a logical key, you can. There's another specification that you can add in here, say generate keys always. And then it will just generate a unique ID for each record on the fly, and that will become your key. But we do have a unique key, even though this is a view. It's sitting on top of a table, and we included the unique key from the table in our view, so we're fine to just go ahead and use the specification. Now, the last part of this, and the most important part, is that we are going to say create using. So for the create operation, we're going to do an override exit. That's what the using. So instead of before or after create, we're saying using. So that's an override. And then we give it the name of an XSJS library, and then the function within that library. Now we haven't created this yet. We'll go create this in a minute. But we're basically telling it what code to branch out to provide all the logic for the create operation. So let's go ahead and save that. And now, of course, we want to add this, so we'll come here to the XSJS folder, because that's the folder name that we specified here. We could have multiple folders. You would just do dots in between them if you had a string of folders. But then you have a single colon, and then the name of the library itself. So XSJS has the concept of reusable libraries as well, and they just have a different file extension, XSJS lib. And anything that you reference from an XSOData as a exit has to be an XSJS lib. So we will add that here. Users create method.xsjs lib. And I have prepared some code for this as well. This is snippet number 16. And essentially what we have here, I have a little reusable function here at the beginning that will validate emails. This is just a regular expression to look at the parts of the email to make sure it is valid. You know, it's got an @ sign, it's got a dot something at the end. We'll use that in a minute. But the main thing is here, the user's create function. That is the function that we're referencing here. So that's how this is connected up. And create exits, the documentation lists the interface of all the different exit types. But basically what we can expect is it'd be passed in by the OData framework is we'll have a database connection already established. So we don't need to connect to the database. We'll have a temporary table that contains the name, a this before table. It's just a string that's passed in, but it's the name of the temporary table that would contain all the data that's been passed in for update and delete operations. And the after table, the name of the temporary table that has the data after the operation has occurred. So what we have here, that would be for create and update events. So what we see here is we're just going to grab that table name, and then we're basically going to say select star from and make it a dynamic SQL to read from the temporary table that contains the data. So the OData framework is going to take all the data that's come in the JSON format, process it, so it's not JSON anymore, and write it into a database table, a temporary table that's very easy for us to read. And once we get that, then we're going to actually turn it back into JSON data so that it's easy to process in JavaScript. And I'm just going to log the data here as well for troubleshooting purposes, so we can see it in the log when we execute this. And then I'm going to run some validation code on the email. And if the email address is not valid, then I'm going to go ahead and throw an error. And this will take us out of processing. When you throw an error condition out of an exit, you return control to the generic framework, and then it's responsible for responding with the standard service framework to produce this error out. I don't have to worry about setting response codes or statuses or building the body of the response for an error. The generic framework will still take care of all that for me. But assuming we get past the validation, then I just want to do an insert into my actual target table via the synonym. And I want to insert the first name, last name, and email columns. I pass the values in. Notice I don't have to specify the key here. We have a sequence. If we would go back, let me just show you that real quick. And when we defined this table, we attached a identity column, which will generate a sequence for that column. And as long as during an insert you don't specify that you want to insert anything in that column, it will automatically generate a unique ID for us. So we don't have to worry about going and fetching that or passing that in. And then what we want to do is we want to set the values that came in from the temporary table. We could do other manipulation of the data at this point before we insert it, but all we really wanted to do was this validation, and then we execute the update and close the connection. And that's all we need to do. That is our exit mechanism. Let's go ahead and run the XSJS service. So we'll pick up the new service. And we can come over here. Oh no, closed our test window, so let's reopen it via the web module. And let's do a test. XSOData user.xsodata. And once again, we could test for the metadata. We see our 4 columns. Let's go ahead and do a get operation. So users $sign format equals JSON. And there is our get operation. Now the get operation doesn't utilize our exit. Obviously, if we want to do an exit, if we want to trigger a creation, we actually have to do a post into the service, and from the web browser alone, we can't easily do that, right? We can only do get operations. So what we would need is we'd need to build a user interface, which we will do later, or we could use a specialized tool, like for instance Postman, that would allow us to manually create put and post operations or delete operations to be able to test out all these different more complex operations rather than read. And a good tool to do that is a tool called Postman. So let's now see how we could use Postman to test our service, even for other operations rather than read, before we build our user interface. So let's take the Postman tool and see how we can use it to test our create operation. Now, the first thing that's going to be a little bit more complicated about going in through Postman is we're not going to go through the web module, and therefore we don't have it creating our access token for us. We're going to have to do that within Postman itself. So what I want to do is first I want to get the full URL of actually the XSJS service, not the web module, and we'll put that here. And then we want to take the rest of the URL to call our OData service. I'll grab that, and let's put it in Postman. And take the extra / off. And if I were to do a GET request, just like we did from the web browser, I'm of course going to get unauthorized, just like we would if we went in the web browser and we went directly against the XSJS service. There's no call to the UAA service that the web module normally does for us. Now, what we can do though is we can come here in Postman and we can tell it that we are using OAuth 2. That is what the UAA service of XS Advance uses, and we can tell it I want to get a new access token. This is the security token. This is the stuff that the web module is doing for us normally. And what I have to do here is I have to give it the URL of my UAA service. And you can look this up in your system parameters, what your UAA is, and then just add OAuth token to the end of it because we want to request a token. And then just like we would do if we went through the web module, we'd have to type our username and password in to the logon screen. So we do the same thing here. That becomes part of our token. But this is the part that you may not know how to get, the client ID and the client secret. And this tells it which UAA service instance that we're going against, and then a client secret. For each binding of that UAA service to a particular application, a client secret ID gets generated. Now we can get this information if I would go back here to the Web IDE, and I would jump into the XS Advance cockpit, and we drill into our space, and here is our XSJS service. We can go to the environment variables for a service, and I can see what the client ID is, and I can see what the client secret ID is. So you would just take this value and you'd cut and paste it and bring it here into Postman. Now I've already done this in advance. I've brought over the client ID and I've brought over the client secret. So we can then just say request token, and it has gotten the access token. We say we want to use that access token, and then once you have your chosen access token, let's put it in the request header. That actually generates an authorization bearer header token. And this is everything, we've sort of been talking about it rather mysteriously. We said, oh, you always have to go through the web module. It generates the security token. It does the work to talk to the UAA. This is what it's doing behind the scenes. It is taking the bound client secret, it's taking the UAA instance ID, it's making a request to the UAA service, it's getting that bearer token back, and then it's injecting it into the header so that all subsequent requests from the web browser will forward this header back and already have the security token in it. So no big mystery about what it's doing now. You've seen what it's doing, and you see we can replicate the same thing here inside of Postman. So we'll go ahead and do a send, and now instead of unauthorized, we get our data back, just like we did when we ran it interactively in the web browser here. Now we want to do a create though, so that's going to trigger a post operation. So what I want to do here is I want to take the same URL, and let's just create a new tab here, going to the same URL. And instead of a GET operation, which is what happens automatically from a web browser, we want to do an HTTP post. And that will tell the OData service that we want to do a create. And we have to do the same thing. We have to load our authorization. It's OAuth 2. Now, one of the nice things is actually Postman remembers the tokens, so we don't have to go through that whole process again. It's automatically brought in the token. We can just inject it into our header. So now we see it here in our header. And now we're ready to do a post. Now we don't type, we got to tell it what data we want inserted. That will go in the body of the post. So and we want to do a raw body of type JSON. And basically we can take the JSON data from our GET request, and we'll come over here and we'll put it in our post. We don't need the metadata. We can beautify it, and we can make it whatever we want. Test exit, and maybe the user's last name is user exit, and we'll call this test exit at sap.com. The user ID, we had to pass it in because it's a required field, but we're going to use the sequence to actually insert that into the database, the identity column. So you can put in any dummy value you want. It's going to be ignored. And now when I hit send, I got forbidden. I must have done something wrong there. Let me see if I grab the wrong access token. I've got two of them here from two different requests. I probably used the wrong one. Preview. I did the header. Let's send this again. Yes, that time it worked. And what we see is that the data is repeated back out to me. Test exit, user exit. But more importantly, if I go back here and we look in the log, remember we did these console logs. So we see in the log of the XSJS service, we see that data being logged. So we know that our exit is being triggered. And then, of course, if we really wanted to verify things, we could come here to our container, and we could go ahead. We could look at our view for user view. And open data, and if we see our raw data, here's our test exit, user exit, test exit at sap.com. So the data that we just typed in Postman got recorded in the database table. And just to test our logic that looks for proper formatted email addresses, let's take the @sap.com off the end here, and let's try to send this data in. And what we got is we got a 500 internal server error, and we got our custom error message, invalid email for test exit, no way, email must be valid, and this email address has problems. Well, that is the logic that we coded here in our exit. That is checking to validate the email, and if it isn't good, then we threw this custom error message, and that's exactly what we see being passed out back to our service. So what we've seen in this video, two very important things. We've seen how we can do create, update operations using exits in OData, but we've also seen how we can test more complex operations using a dedicated tool like Postman. Now Postman is, I should state, it's not an SAP provided tool. It's something, some open source tool that you can go download from the internet and utilize yourself. Of course, there's other similar tools, but we see how even before we've created our user interface, we can still test more than just GET operations utilizing a specialized tool like Postman.